In some ways, the final journey of the Space Shuttle Endeavour was its most daunting, even though it never left the ground. For more than 60 hours, the shuttle crept 12 miles through the streets of Los Angeles, dipping under streetlights and brushing past homes. A logistical ballet that was well worth the effort, because it marked a homecoming for this pioneering spacecraft born right here in Southern California.
This program was made possible in part by a grant from the City of Los Angeles Department of Cultural Affairs.
Just remember that you're standing on a planet that's evolving, revolving at 900 miles an hour.
Good morning, Endeavour, and welcome to another great day to be working in space.
So it's reckoned the sun that is the source of all our power.
Born from the ashes of tragedy, Endeavour was built to replace the fallen Space Shuttle Challenger. As the final addition to NASA's shuttle fleet, it embarked on 25 missions between 1992 and 2011. From fixing the Hubble Space Telescope to assembling the backbone of the International Space Station, Endeavour left an indelible mark on space exploration. But its legacy isn't just written in the stars, it's also etched in California's history. To witness this symbol of Golden State innovation up close, I headed to the California Science Center, where Endeavour, now attached to its rocket boosters and fuel tank, poised for launch, will take center stage in the museum's massive new Air and Space Pavilion.
So Ken, this is the most massive artifact we've ever explored on Lost LA. And I think when people look at the shuttle, at first glance, they might not think of it as a historical artifact of Los Angeles history, but it really is.
It was fabricated here in Southern California, in Downey is where it was designed. And then they were assembled to take them up in the desert, and that's where they were trucked. And whenever a shuttle would land, at least in the early days of the flight, it would land up at Edwards Air Force Base.
Growing up, I heard those sonic boom.
It's an amazing thing to experience a supersonic object coming back into the atmosphere like that. You could actually feel it.
Discovery now going subsonic, the fleet-leading shuttle announcing its arrival at the landing site with a pair of sonic booms.
Main gear touchdown, pulling the drag chute.
So the Endeavour is in the process of becoming, if it's not already, one of the major monuments in Los Angeles, right? Along with like the Hollywood sign and, Disneyland, right? What does it represent?
I think it represents a major accomplishment that human beings have brought about. I mean, Endeavour was a bridge program between the very early days of spaceflight, when we were trying to just get control over the machinery that we were flying, and the ability to become really proficient in space and to go again and again and again, to a designated space station that Endeavour and the other flyable or space-worthy orbiters in the group assembled. They built it in space like it was a tinker toy. And just think of the proficiency that it took to do that, how much dexterity you had to do. And that's what the Space Shuttle program was all about. Plus, it introduced space exploration to a wider range of people that had ever flown before, all walks of life. They were engineers and scientists and men and women, and many of the people were biologists.
See a beautiful space shuttle there. That's this beautiful Endeavour. She's a great ship. She looks like she belongs right there.
So we should probably put some safety gear on. Safety first?
Once the construction workers cleared out for the day, Ken and I went in to marvel at the stacked shuttle.
So orbiters on the left, the big orange external tank. You get closer to it, you really feel like you're an astronaut or like an engineer.
And it looks like it could take off any second, right?
Yeah, and that's the whole point.
Since Endeavour's dramatic arrival in Los Angeles in 2012, it's become an iconic symbol of the region's aerospace history, drawing millions of visitors to the California Science Center. But just a few miles away, another shuttle, almost forgotten, lies dismembered under plastic tarps in a municipal maintenance yard, hidden in plain sight.
So this is it right here?
This is it. This is the shuttle.
Ben Dickow directs the Columbia Memorial Space Center, and he sees this mock-up as more than a relic. Once the Space Center's expansion is complete, the mock-up will rise again, reassembled for permanent exhibition.
This is the very first space shuttle ever built. It's the full-scale, one-to-one mock-up of the shuttle. It was built as an engineering tool to figure out how do you build a space shuttle, because there was no CAD or anything like that.
Right, you just had to build it.
You had to build it and then figure out how things fit. And this was built in 1972.
So this mock-up obviously never went into space.
No, right.
It was built to show what the space shuttle could be like.
Exactly.
It was a sort of a concept,
Right.
but then it also had use after the shuttle program was approved.
Oh, absolutely. So as the shuttle program got off the ground and engineers were trying to figure out how to fit things in here, right? They'd come here and they would use this as the actual model to try to fit little pieces and parts and everything. This had hydraulic lines and electrical lines and everything sort of mapped out in here.
So it wasn't just a model to get this shuttle approved.
Absolutely
it was also
not.
a faithful replica.
Absolutely.
And whenever they made a change to the actual shuttles that flew,
They would make it here and then make the change. Yeah.
Okay.
No, this was a tool. This was absolutely an engineering scientific tool.
At Edwards Air Force Base,
Yeah.
there was a lot of testing on the shuttle done there. The Enterprise drops.
Absolutely.
And of course,
Yeah.
I mean, even the first landing was in one sense a test. But all of that testing only happened after just a ton more testing here in Downey.
Totally. When you think about the first flight of Columbia was in April of 1981. They had just gotten the contract basically 10 years before. So in all of that time, all that stuff had to be tested out.
I've seen some photos of work being done at the Rockwell plant, and I have to say that the photos are remarkable in that the workforce was pretty diverse.
Picture a NASA engineer from, especially 50 years ago, right? Short sleeve, white shirt, white guy with crew cut, right? And a pocket protector.
Pocket protector,
Exactly,
of course.
exactly. And there were certainly some of them there, but that was not the vast majority of the workforce. It was super diverse. It reflected the multicultural sort of Southern California atmosphere. A lot of people are coming from other parts of the country here to work on this site and on this program. And the engineering workforce wasn't even the major workforce here. This was mostly blue collar, highly skilled technicians who could bend metal, who knew how to solder really well and all that kind of stuff. They're just as important in this story as the theorists or anybody doing the slide rules and the calculators.
So the safety of the astronauts, their very lives depended on the work that the engineer and the craftsmen and all the blue-collar workers did here.
Absolutely. Kind of going a little bit farther back, the Apollo 1 story is kind of interesting here because when that disaster happened in Florida, there were Downey crew there, and then Downey got the first phone call because we're the manufacturer. Who do you call if you have to get something repaired, right? You look in your owner's manual and you see who built it, and you say, hey, what happened? That's exactly what happened here. So the responsibility of this site and the people on this site was pretty big.
Let's go take a look.
Yeah, sure. Let's do it. So this is like where all the wiring, all the utility and stuff like that is. This is the floor of the mid-deck. This is where they were sleeping, toilet, all that kind of stuff. Right above that is the flight deck with the pilot seat, the remote arm manipulator going that way.
Wow, there's actually a lot more space in here than I would have imagined. Pretty cool. Just down the road from this maintenance yard is what many aerospace veterans consider hallowed ground, the former site of North American Rockwell's Downey plant. In the 60s, this sprawling complex was the birthplace of the command and service modules that took Apollo astronauts to the moon. By the 70s, the plant's 35,000 workers were forging the future of space travel, the Space Transportation System, better known as the Space Shuttle. Though the plant shut its doors in 1999, and today big box stores and parking lots cover most of the site, one piece of its legacy remains, the Columbia Memorial Space Center. Ben and I sat down there with several Rockwell engineers who helped turn the dream of the space shuttle into reality.
Whatever happened to that mock-up?
Still over there.
The mock-up was to have the design of 3 groups done together before they built the real thing. So that here it is. All the parts were made, designed, made, fit, no problem.
It's all wired too.
Wired, everything.
There's no RFP, there's no proposal, there's just backroom talk and chatter about what they're gonna want.
But you built this thing before NASA had even decided to fund it. So you have a sheet here on the mock-up, Space Shuttle mock-up. 1972, okay. Yeah, right here in the Rockwell facility in Downey.
Right.
Everything that's in the space shuttle, aside from like the actual inner workings, but all the hydraulic lines, all the wiring, everything is in this mock-up because it was not meant to just be public showing so that to get public opinion around it, but it was also meant specifically for internal
to do the job,
to make sure, to see how everything's going to fit, to see how the systems are going to work together.
When we bid the contract, NASA said we want a vehicle that will fly for a minimum of 10 years or 100 missions. That was the warranty we gave them. That came back to haunt us later with Challenger and Columbia. We bid to what the customer wanted, and they said, we need a space truck. We've been to the moon, been there, done that, let's move on to the next thing.
Space truck, is that what they call it?
That's what we call it.
It makes sense, it's bringing cargo into space.
And then we won the Space Shuttle program. And I got the opportunity to build a nice laboratory in the basement of the world's biggest clean room.
The world's biggest clean room was right over here.
Yes.
Wow.
It was over 100,000 square feet.
I came into Rockwell very late in the shuttle program. In fact, Endeavour was almost completed. I had come in pretty much just right out of college. I specifically came in on the manufacturing side to get the drag chute done. Ironically, the first vehicle to have the drag chute was the last vehicle made.
Isn't it an original feature?
No. The main reason for the drag chute was it became pretty apparent that there needed to be the flexibility to land the shuttle on different runways. With the drag chute, you could land it in numerous places. But I had the absolute glory of being able to work with my father.
And you worked on the same shuttle program, is that right?
Yes, well, and not only so, my dad here, Pete Magoski, he was like a big fixture at the plant.
These were works of art. When the contract for Apollo came out in '62, nobody knew how to build a spaceship to go to the moon. It's not like you're mass producing these things. There's only 7 shuttles built, and when you take out the technology part of it and you think about these things as objects, it's pretty amazing.
Several crucial components of the shuttle orbiter, including the crew compartment and 3 fuselage modules, were manufactured at the Downey plant, then trucked overland to Air Force Plant 42 in Palmdale for final assembly. I tried to visit, but classified. So I made my way instead to Edwards Air Force Base, where the finished shuttles took flight, piggybacked on a modified 747 en route to Florida for launch.
Edwards Air Force Base is a pretty significant site in the history of the space shuttle. But there is just a lot more aviation and aerospace history associated with this place.
There is. In many ways, this is where aviation came of age.
I met up with Edwards Air Force Base historian James Tucker, and we set out for a guided tour of the base.
So yeah, these tunnels were built to allow scientists to transit from any of the test sites to others, even while there were active tests going on.
So you could be down here while they were testing the rocket fuel and you'd be safe.
Exactly.
Okay.
It's the entire point.
Few places loom larger in the annals of aerospace history than Edwards. It's where Chuck Yeager shattered the sound barrier, paving the way for future milestones. The X-15 pushing into hypersonic speeds, the first Saturn rocket engine tests, and on April 14th, 1981, the triumphant landing of the first space shuttle mission.
In order to ensure that our ground crews could properly extricate the shuttle crew, we had this trainer built to allow the ground crew to train to pull them out should there be a fire, should something go wrong with the landing, so that there was a safety protocol in place. And this let them train for it in nearly lifelike conditions.
So what is it that brought people here? I mean, it's got to be this amazing lake bed, right?
Yeah, this lake bed, known as Rogers Dry Lake Bed now, originally called Rodriguez Dry Lake Bed by the Spanish, is a natural, what they call pluvial lake. It is a dry lake bed formed from the last ice age, and its surface is made of what's called bentonite clay. That clay is a natural fire retardant. And at 44 to 47 square miles of lake bed, you can land almost any aircraft here. In fact, as far as we know, this lake bed will support any current or theorized air or spacecraft in the world.
The Columbia landed here, right? And actually earlier, the Enterprise landed here when they were testing it. What made this place perfect as a landing site for the space shuttle?
I would say that the biggest factors are, first off, the lake bed. With its tremendous landing surface, with its high visibility, you can see this as you descend from orbit with the naked eye. They say from above Guam, is how far away they could aim for this visually.
So the shuttles above Guam can already see this lake bed?
As it's descending, yes.
Wow.
But in addition to that, if you look around us today, this is almost a perfect Edwards day. We have 300 plus days of flying weather here. And so when you're looking to set aviation records, when you're looking to test any kind of aircraft, or when you absolutely have to get the landing right because space shuttles only get one try.
They're not powered when they're landing.
Correct.
Yeah.
And so you only get that one shot. This is the kind of place you want to do it.
Yeah.
With only one shot to stick the landing, the shuttle had to be proven airworthy before it could ever soar into space. In 1977, a full-scale test vehicle named the Space Shuttle Enterprise, yes, after Captain Kirk's starship, flew 16 missions in the skies above Edwards. At the controls, those fearless few, trained to push the limits of what's possible. Test pilots.
Well, we're at the end of the approach and landing test phase of this program, but it's really not an end, it's a beginning as we continue on toward that first orbital flight.
So each one of our graduates will send back a plaque from their mission.
It's all the space shuttles.
Yep.
Wow.
Lieutenant Colonel Maryann Karlen is deputy commander of the Air Force Test Center and a test pilot herself. She shared what it's like to fly unproven aircraft at supersonic speeds, thousands of feet above the ground.
This is the Scobie Auditorium, which is named after one of our graduates. He was actually the commander of the Challenger when it crashed.
Oh, so he was both a test pilot school graduate and a space shuttle astronaut. So every Air Force pilot must have a lot of talent and a lot of training, but you teach a very specific skill set here?
We do.
Yeah.
So we take a pilot, like you said, that has had very specific training, and then we level it up, if you will. So we layer on engineering, and specifically flight test engineering. So I've done a lot of neat airdrop testing for programs like NASA. So the Orion capsule, how do you test the parachute system for that? Well, you airdrop it out of a C-17 and test the parachutes as it comes down.
And you flew that mission?
I did.
Wow.
Several of them.
Wow. So there are actually a lot of connections between the test pilot school and the space shuttle program.
Yeah. The space program in general, we've had a lot of our graduates go on to become astronauts. Back in the 1960s, we actually stood up an aerospace research test pilot program to be able to help the Apollo astronauts prepare for their missions.
What do you think the astronauts who flew those very first missions, in fact, the very first, were thinking as they were preparing for that and flying that mission?
I think what they were thinking was, wow, I'm glad I had a lot of test pilots flying this before we actually took it up into orbit. So they did a lot of drop testing here to be able to come back and say, okay, before we launch one of these things and come back down, what can we do to mitigate those risks here?
There has to be some sort of special resolve within you to fly an aircraft or a spacecraft that has never been flown before.
Yes and no. You know, yeah, you have to be able to look at something and go, hey, here's this risk and I'm willing to accept it. But you also know the process, right? It's not, I'm a cowboy and I'm just gonna go and see what happens. There's a methodical approach to looking at, hey, what technical data do I have to get out of this, and how do I get that, and how do I get it safely? And are there different things I can do to mitigate that risk so that by the time you're climbing into that cockpit, you've prepared yourself and you know the team's prepared for it.
How often do you think about all of the people who contributed, the engineers, the designers, the people who put it together?
All the time. Flying the C-17, right? That aircraft is so built for its mission. And you sit there and you're like, man, I wonder what that test pilot did, that test loadmaster did, you know, to make sure that this fits seamlessly into the mission that I need.
In a very real sense, your survival depends on their work, right?
Yeah, absolutely.
After landing, astronauts would head into this trailer for a quick medical checkup before facing the press.
These are all the astronauts who used this vehicle. Wow.
Yeah. 54 landings.
One of them was San Fernando Valley-born Downey Olivas. He flew 2 shuttle missions, including one that touched down at Edwards in 2009.
The crew of STS-128, the Space Shuttle Discovery, we're very happy to be back on land here in California.
Danny and I met up at one of the few places in Los Angeles where we earthbound mortals can glimpse the cosmos, the Griffith Observatory.
So this is about as close as most Angelinos will get to seeing space with their own eyes.
Yep, get you up close and personal.
In a sense, yeah, looking through these telescopes here. You've actually been up there twice.
Yep.
And I've read about this phenomenon called the overview effect.
Oh, yeah.
Did you experience that?
Absolutely.
Describe that to me.
The easiest explanation is that you come to appreciate yourself as a human being relative to the cosmos. You know, the borders that I noticed from space were those between the water and the land, and there's really nothing else.
So you grew up for a few years in Los Angeles. You were born in Los Angeles, and then you moved to El Paso, but now you moved back to LA. Southern California has a lot of claims to fame. But I wonder how many Southern Californians are aware that space travel is one of them.
You know, when NASA was looking at where to place the Space Shuttle orbiters, when the Space Shuttle retired, it was natural for Space Shuttle Endeavour to actually make her way home where she was born. Being able to bring her back home and get people to fully appreciate what can be done out here, and the creativity, the ingenuity, the kind of forward-looking way that I feel is the vibe here in LA.
The shuttle's gonna be coming down this show right here. This is one of the historical boulevards in our neighborhood, and it's gonna be a beautiful historical site.
I try to look at it as a monument to the huge labor force that went into creating the space shuttle, right? We're talking about tens of thousands of not just engineers, but skilled tradesmen. It's a huge contribution.
Well, and in fact, it's in that contribution that I found my inspiration to become an astronaut. I was born in the Valley. At the time, my dad was a machinist, and he worked for, you know, subcontractor of a subcontractor. So pretty far deep in the whole subcontracting pool. But there was a machine shop, and he built parts. And I remember, ultimately, when we moved to El Paso, we took a family vacation to Houston. We were going through the museum, and I remember, of course, me being a child of the Apollo era, I was inspired by what I was seeing because I love looking through my $15 telescope at home in West Texas, El Paso, at the sky and at the moon, and just thinking to myself, space is cool. And then knowing that human beings went there, even cooler. So we're walking out of the museums and we're getting ready to leave, and my father calls us over, me and my sister and my brother, and says, hey, I want to show you something. And so he's standing in front of a mock-up. He begins to start to explain to us some of the parts that he made when he worked for this company, Gamma Precision Products. I remember thinking to myself, wow, my dad is part of what made that happen. Yeah. And it was a great sense of pride. But then as I looked at this rocket engine, I saw all these other parts and pieces that weren't from my dad. They were from other dads and moms and, you know, aunts and uncles and brothers and sisters, right? Yeah. I think for me, that was my inspiration, that's what I wanted to be. Not necessarily to build a part, but to be part of something that the accomplishments were a collection of what everybody could contribute and pull together. So space is not about one person, not about a person who wears a blue flight suit, but what everybody does to actually make it happen.
My grandfather worked at North American Rockwell
yeah.
in Downey and specialized in something called microconnections. I still don't really know exactly what that is, but he worked on the mock-up. And so the shuttle was always a special thing in our family. And when he got to see Endeavour come to Los Angeles, I know that was a really special moment for him. So when I look at Endeavour, as I'm sure you do, I see a lot more than just a space vehicle. It's really a monument to our region. Your father, my grandfather, there are tens of thousands of people like them who contributed to this. It's a big collective effort.
Well, and human spaceflight, as I see it, as much as it is about exploring the universe and the natural world around us, the human spirit, the human capability for ingenuity and creativity and innovation and skill.
I've been thinking a lot about how we should think about the space shuttle's legacy, what its place in the broader narrative of space travel will be.
I personally think that the space shuttle program's legacy is actually one that has nothing to do with science. It has to do with society, and that is that the space shuttle program ushered in a level of diversity that our country had never seen before, where in this one area of space, we have found a way to work together. The Space Shuttle program saw its first female astronaut. We saw its first
African-American male, African-American male commander, female African-American, Hispanic American, all these different groups that represent America now had an opportunity to showcase that there was a place in them in this grand experiment, called space exploration.
For somebody who's not an astronaut or an engineer, how can they contribute to the future of space travel?
So one of the, I think, the greatest things about space that people don't know is how much space there is in space for everyone. But the fact of the matter is that every aspect of life touches space. So whether you're talking about a journalist who's interviewing people about space, whether you're talking about lawyers who are developing contracts, business development groups who are trying to nurture brand new small businesses, or artists or educators, there is a lot of space for people who are enthusiastic and passionate about space to bring their skill set and to help contribute that basic human desire to explore the cosmos.
3, 2, 1. We have ignition. We have ignition of the solid rocket boosters and liftoff. Liftoff of America's Space Shuttle.
I'm proud, just like Apollo. I'm proud to be part of it. We are so privileged to work on this program.
Best flying machine there is. Best flying machine.
It makes us proud to just be a part of the team and know that we're the few in the country that can do this kind of a job.
That's true.
I think it's very exciting to be involved with a company that is doing something like this.
I feel very privileged. Everybody doesn't have a chance to work on a shuttle.
A lot of my friends, when my wife or I will tell them that I work on the space shuttle, they seem to be pretty impressed. And it makes me feel good. I'm pretty impressed with the job, too.
This program was made possible in part by a grant from the City of Los Angeles Department of Cultural Affairs.